Hello everyone, my name is Tim de Bouw, and I'm excited to present you AdapTables, a system that I built during my master thesis. Uh, so when we were thinking of a subject, we were right in COVID times, where all meetings were done using Zoom or Microsoft Teams. And I think I speak for most of you that we really felt the limitations of those technologies. So I thought of what is, in my opinion, the ideal immersive meeting. And that is when two people can be in vastly different environments, but still talk with each other as if they're present in the same room. And I think this can be achieved using augmented reality. So with my thesis, I try to take the first steps to solve this problem. And because this is such a big problem, we mainly look at the differences between the shapes of the tables. So as you can see here in the example, we have a circular and a rectangular table. And somewhat similar things have been done in the past. As you can see here on conformal redirected walking, where two people in different rooms can work together in a shared virtual environment. They can see each other's avatars and walk around, but there's very limited interaction with the space itself. And then the next example is merging environments. And here you have, again, two people in different environments, but they can again work together and see each other in their respective environments and can have a little bit of interaction. And as we mentioned in the beginning, in this ideal immersive meeting, we want to have an extension to augmented reality. So with my thesis, I wanted to extend on this on this solution by introducing the aspect of augmented reality and have a higher sense of interactability by introducing movable objects. So to do that, we use a concept called conformal mapping. And here you can see an example of the map that we use. So conformal mapping warps the space from one environment to the other. And here you can see a warpage of a circular unit sphere to a square environment. As you can see, you need two types of maps. One map for the points onto the table and one map for points off the table. And when we use this in practice, it looks like this. On the top you can see a square table that is mapped onto a rectangular table, and this is very basic to solve. You basically need to elongate it in one direction and squish it in the other direction. But when you look at a circular table, for example, you can see that those conformal maps come in play and they warp all the objects on the table. So as you can see, on some parts they get more squished, on some parts the lines that are straight on the circular are not straight anymore. So now we want to test this system, and with our tests we focus on the effect on presence, meaning how immersed are they in the environment, and workload, meaning how difficult were the tasks to perform. We have two participants, one augmented reality user and one VR user, where the augmented reality user stays with its physical table and the VR user iterates between a rectangular, a circular, and a square virtual table. And our aim is to look at the differences between those tables. So when we analyze these effects, we can see that there are some differences between the VR and the AR users. So between the devices, you can see that the VR users experience a lower workload and a lower completion time for the tasks. But when you look at the differences between the tables, you can see that there's not really much difference. They mainly have the same interaction, and basically no one noticed the differences between the tables when they were performing the study, or that the tables had a different shape during the study. So taking those metrics into account, we can say that the devices had a significant effect on the study. there are differences between VR and AR, but not no effects on presence that could hinder the results of the study. And next, we can say that the usage of the conformal maps to warp the tables has very little effect on the workloads and presence, meaning that it doesn't really matter for the participants to if the table is mapped or not. And if we take those two things into account, we can say that this system is usable for introducing augmented reality users in a meeting room context and to bridge the gap between augmented and reality users. Thanks a lot for listening.